All right, guys, let's go over this. Number 1. Who's got whether that's true or false? Yeah. False. I agree with that being false. Could someone else describe a situation where you have R over S equals something that is in fact true? Yeah.
A over J.
A over J. Let's check that out. So R over S. We said anytime we're dealing with this R over S, even though there's parallel, we have to go back to similar triangles. So R over S would be this small triangle over this big triangle. So the small triangle would be A over the big triangle, which would be J. That is correct. Number 2, is that true or is that false? Labib.
Yes, it works.
It works? Yep, so that is true. This one is true. It works. That is J over A, so it's, I call this whole over part. So it should be whole over part of something else. So that'd be S over R, which is true. Real quick, if I have J over A, can someone come up with another statement that's true?
J over A.
If I have J over A, what's another statement that would be true?
K over N.
K over N? That's what you just stole it. Yeah, Sangha.
You can do S over R.
Oh, we already had that.
Oh,
But yes, K over N would be correct because this is whole over our top chunk, and this would be whole over our top trunk. Would J over B equal K over T?
yes.
I'll say that again. J over B, does that equal K over T? I think that's a T. Can't really tell, it's smudgy. Yeah, that would work as well. Would J over B equal K over N?
No.
No.
Would J over B equal K over N?
No.
Nope, that one would not work. Because that would be this whole over kind of that bottom chunk, whole over top chunk. They don't match up. All right, so realistically, if it's parallel, if you have parallel lines, you have pretty big freedom how you can write it, as long as the parts you're choosing are equal on each side. So if I choose A over N, I better choose B over T. All right, you have a lot of freedom once you have that parallel line. The only thing that locks you in is R and S. That locks you into what the other side has to be. All right, questions on the bell work? Dabbing? No, just stretching. All right, then what questions do we have from the homework? Once I find our homework. Okay, yeah, questions from homework. Jacob. 17. You know what? I don't think I actually have last night's homework.
Oh, sorry, no, 16. Sorry.
Oh. 16 you said?
Yeah.
Okay. So 16. 16, if I'm correct, at 116, we were given this little drawing. Let me take a picture of that drawing. Actually, let me take a picture of all of it, and then we'll talk about how I got the answers I did. All right, 16. Let's try to delineate between what I wrote down and what the book gave us. So I'll circle the stuff the book gave us. The book gave us 18, 26, 12, and 36, correct? So it said RT, so the whole length from R to T is 18. Then it gave us from N to P is 26, so this is 26. And then it gave us T to P. T to P is 36. I missed one. R to N is 12. Okay, so if I did something like, let's say I did 12 over 36. Correct? Well, that would be equal to whatever the length AR is over this full length. So what I'm going to do is rather than writing AR, I'm just going to write it as X. Okay? So this is going to equal X over, and what I'm going to write this as is X plus 18. Now when I do my means extremes, we're going to have 36 times X. So I'll have 36X is going to equal 12 times X, which is 12X. And then let's make sure everything's working out. So we'd have 12 times 18, which is going to be equal to 216. 216, yeah. Subtract 12x from both sides. That will give me 24x equals 216. When I divide 216 by 24, that does come out to x equals 9. And we can plug that in there. And now that I know 9 and 18, we know AT equals 27. And we're going to do the exact same thing for AN to get to AP. Does that make sense?
Yeah.
Okay, good. Yeah, Alex.
Can I go to the bathroom to take off my contacts?
Sure. Do you have any questions on the homework real quick?
No.
No. You just don't want to see us? Is that the trick? Yeah, go ahead.
Yeah, okay.
Other questions from the homework? Yeah.
Is something like this going to go in the test?
Why couldn't it be?
We're learning it.
Because we're learning it and it's in the homework. The only time something won't be on the test is if I say it was like a challenge question. I'm like, don't worry about this. This won't be on the test. In fact, you can expect problems like this on the test. It might not be formatted like this. But I mean, realistically, all I did is this is 1, 2, 3, 4, 5, 6 different pictures. And rather than having to draw 6 different pictures, this way I can draw one picture and you have to do the work of the drawing.
Because the graphing, the table makes it kind of confusing.
The table does make it confusing. So most likely we won't have the table on the test, but the same type of problem is on there. Remember, if you're given a table, just draw a picture. Just like on the test. Draw a picture. If you draw it wrong and solve it wrong, at least I can see why your picture's wrong and I can give you points based upon that. Yeah.
Oh, no, I was just, because I was just going to ask it. You give us one picture, can you just fill it in each time?
Yeah. Yeah.
That's what I did.
Yeah.
But then it would be erased. And you could
Yes, but you can always grab a scratch sheet of paper. I know some people grab scratch pieces of paper and they do all their drawings on there, and that way I can see all their drawings if they don't think they have enough space. If I would do a table like this, I'd give you plenty of space that you could draw all the pictures that you want, because I do want you to draw pictures, especially on a test. If you're just on homework, maybe you take a shot at it without drawing a picture, maybe. But if you're on a test, you definitely draw a picture, so you'll have room. Okay. Other questions? All right, let's go ahead and go through today's lesson. You can look at today's lesson. It is just that front side. Our lesson is going to be really short. The homework isn't super long either, and that's why you have your review, just in case you run out of stuff to do. You can start working on your review. Reminder, test is on Monday, not Tuesday. Monday. It is on Monday, so that means we have a review day tomorrow. We have a review day on Friday as well. So you don't have to stay up till 2 in the morning tonight finishing that review packet. You have 2 days to work on it in class. All right, angle bisector proportionality theorem. The angle bisector of a triangle divides the opposite side of a triangle into proportion with the sides adjacent to the bisected angle. Whew, we nailed it, right? Do I even need to show what that means?
Yes.
That's pretty. You need more than that? Okay. So let's go ahead and look at this. So the first thing I'm going to look at is, see those 2 little tick marks on each angle? That means it's an angle bisector, if you remember. An angle bisector cuts an angle in half. So what I circle right there is what you're looking for, and that means this is an angle bisector. Yes?
Would that mean that the side opposite of it is bisected?
No. It just means the angle is.
Like, how would that work? How could the other side not be bisected?
It depends on the angles. Like, this can be angled really weird.
Oh,
If it's We did have a rule if it's isosceles, then it would bisect the other side. But anything else, if it bends it, then we don't know it's cutting it in half. All right, because you can picture the extreme version of this where it's like really big, and you're like, okay, that probably isn't. Yeah. So we're just going to stick with angle bisector for right now. All right, so it's an angle bisector. In fact, because we don't know they're congruent is why we have to use this. Okay, so we have an angle bisector. If I have an angle bisector, then we have something with proportions. And what this theorem's actually saying is, well, if you do A over N, that's going to equal, anyone want to take a guess what that equals? If I started with A over N, who wants to take a guess at what that equals? Alex?
B over G.
B over G. Perfect. Or, does anyone want to finish this statement for me? I'm going to go A over B. Just knowing things about proportion, if I do A over B, what do you think the other side of the equal sign is? Davion? It'd be N over G. Yep. And those are our two ways to do that. All right, that is all that theorem says, is that if you see an angle bisector, then you can do A over B, because N over G, or A over N and B over G. Okay, pasta, Krupa.
So you can't do that A plus N over N equals G.
You could. Yep, you can always do that. So you're talking about adding the denominator, so that would be A plus N over N equals B plus G over G. I don't foresee you ever needing to do that, because usually we use that if I want to see like a whole side, but because we don't, it's not two sections of a triangle, it is kind of jointed, we're probably not going to use that, but that is 100% true. All right, questions on this theorem? Once again, yesterday and today we're provided key information to be able to use them. Yesterday we said you first have to find a parallel line. This one says you first have to make sure you have an angle bisector. If you do not have parallel lines or angle bisectors, you have to go all the way back to square one and have similar triangles. All right? Stay on top of that. You're looking for parallel lines and angle bisectors to use yesterday's lessons and today. If you don't have those, you have to go back to similar triangles, facts, and getting scale factors and making it equal. All right, let's go through a couple problems. First problem is I'm missing A. Well, these can't be super complicated problems because you're going to locate your angle bisector and go, okay, I can use this particular theorem. And you can set something up like, well, if I'm looking for A, we could do A over 18 is going to equal 28 over 42. Question mark? No. No. That would not be right. It would have to be 42 over 28. We can use our means extremes to go, well, 28A is going to equal 18 times 42, which is going to equal 756. Divide both sides by 28. You should come up with A equals 27. Now, we know this is true. We know based upon the whole thing this next statement is going to be true, but let's prove it to ourselves that it's true. Let's pick a different set of fractions. All right, so what I'm going to pick instead of A over 18 is, let's try A over 42. If I did A over 42, what does my other fraction have to be on the other side? So I'm doing A over 42 has to equal what? TJ. 18 over 28. And let's make sure that this is true as well. So I'll do 28A. Equals 18 times 42. Wait a minute. That's still 756. So that is still A equals 27. We are A-okay. Everything works. We're A-okay. As long as you keep things in order, where proper parts go with proper parts. Our next one says we have 24, 40, we have B, and then we have a total length. Well, this theorem doesn't work with total lengths. I can't use 36 directly. I need to actually know this length here. I don't have to know the value of it. I just have to have something standing in the place of it. Now, I do not want to create a new variable. Because once you create a new variable, you have to have two equations. We won't be able to have two equations. So what can we do instead? Yeah. We can do 36 minus b. So if b is 6, this is 30. If b is 10, this would be 26. So this side is 36 minus b. And then we have something for each segment. Now we can go back to our theorem and do something like, I picked 40 over b. What does 40 over b equal? Can someone give me the other side of that equation? I picked 40 over b. What's the other side of that equation? Someone I haven't heard from yet. Krupa. 24 over 36 minus b. Cool. All right, so we'll do our means extremes, which looks a lot like cross multiplication. And we are going to have 24b is going to equal 40 times, well, let's write it all out. 40 times, because people keep messing this up, 36 minus b. So that 40 is actually times that entire quantity. So 24b equals 40 times 36, which is going to be 1,440 minus 40b. Now I'm going to add 40b to both sides. That will give me 64b equals 1440. Divide both sides by 64, and you actually come up with a little bit of a decimal, and that will be 22.5. That is B. Now be careful on these problems. Be careful on these problems because I might set it up that you actually have to give me this line. And if you just solve for B, you found that line. You're not far away, you'd have to do 36 minus it. So make sure you're reading these questions carefully and that you're answering them correctly. I remember on the test we had one that was similar to this, and a lot of people just found this B when I actually specifically said, find this line. So be careful on what you're looking for. All right, any questions for me?